Hi, in this video, I'm going to make a long-form video on revision topic 2 functions for IB Math AISL. The first part is understanding linear form or linear equation, and these are three main forms that you need to know. The first one is gradient intercept form. You need to write it in form of y equals mx plus c. The second one is point gradient form, where you need a gradient and a known point. The third one is general form, in which you write it everything on the left side and equates it to 0. So on the exam, you might be commonly to be asked on what is the y-intercept, in which c is the value of y-intercept, because y-intercept happens when x is 0. And when they ask to write the answer in general form, you can start by finding the gradient intercept form first, or the point gradient form, and then you rearrange the equation everything on the left side, so then you will get the final answer at the general form. Talking about gradient, there are two relationships that you need to understand. The first one is on parallel lines, the gradients are the same. So the gradient from the first line and the second line is the same thing. And on perpendicular lines, where the lines are crossing and make a 90-degree angle, the gradient is the negative reciprocal of the other. And on the tips for exam is the perpendicular lines gradient relationship are commonly out on perpendicular bisectors, and also for normal lines, which is very related to the topic 5 calculus. And this is bridging the linear form and also the function topic. The first one is vertical line, where x equals to a certain constant, and then the second one is horizontal line, where y equals a certain constant over here. So vertical line test helps to check whether an equation is just a relation or a function. If you draw lots of vertical lines and it only crosses one point at that equation, it means that what you're having is a function. And if it's, crossing a lot of points, 2, 3 or more, it means that you have a relation. After you check that an equation is a function, you can go further to do the horizontal line test. So horizontal line test, for you to check whether a function is one-to-one. So if it only hits one part of the graph, it is a one-to-one function, or it is a many-to-one. So let's say like quadratic equations, when you draw horizontal lines, the horizontal line crosses 2 points. So this is called many-to-one function. A function that is one-to-one means that the function has an inverse. But before going to inverse, we can just do the practice questions first. So the first one over here is we have an equation line, and we need to find the x-intercept. So for the first part, it's quite easy to find the x-intercept. X-intercept happens when y is equals to 0. So we substitute to the equation 0 minus 3y plus 5 equals to 0. And y is equals to 5 over 3. So the answer, the x-intercept, happens when it is 0, 5 over 3. Remember that when question is asking about intercept, we need to answer that in coordinate form. The second part is the gradient. We can get this by rearranging the equation. So y minus 3x plus 5 equals to 0. And y equals to 3x minus 5, and we get that the gradient is 3. The second line intersects at 0, 2 and parallel to m1. So we need to find the equation L2 and write it in the gradient intercept form. Now we know that L2 is parallel to L1. This implies that their gradient is the same. So gradient L1 is 3. So the gradient of second line is also 3. And we already have a point in which it is at 0, 2, in which we can use the point gradient form and rearrange that into gradient intercept. So y minus y1, which is 2, equals to the gradient multiplied by the bracket of x subtracted by x1, which it is 0. So open the bracket, we will get equals to 3x, and rearrange the equation, so it will be 3x plus 2, and that is our answer. We have a third line that is perpendicular to the L1 and passing through the point 3, 1. So we need to find the gradient of L3. So line 3 is perpendicular to the line 1. So we know that the gradient of line 3 is the negative reciprocal of gradient line 1. So gradient line 1 was 3, so it is negative 1 over 3, and that's the final answer. So now we need to find the equation and write it in the general form. We have the gradient already, and we need to remember the position of the point Q in which it is at 3, 1. So we can use the point gradient form and rearrange the equation. Y minus 1 equals to the gradient minus 1 over 3 multiplied by x minus 3. As it is in the multiplication form, we can multiply everything with 3. So we get that it is 3y minus 3 equals to minus 1 multiplied by x, which will be minus x. And minus 1 multiplied by minus 3 is plus 3. So we arrange everything to be on the left side. So x plus 3y minus 6 equals to 0. And that's our answer in general form. Now we are going through function properties and features. So function has a domain and range because function is a number crunching machine. So you insert an input in which we call it domain, and you will get an output in which call it a range. And some functions, they have asymptotes in which the line is approaching to certain value. Also, some functions have asymptotes, whether it's vertical and or horizontal. The way you check it is you see the graph, the nature of it when x is going further positive, further negative, or further positive on the y-axis and further negative on the y-axis. And to answer the questions, when you want to get the roots or x-intercepts, you substitute the function y equals to 0. And vice versa, for y-intercept, you substitute x equals to 0 into the function. Remember to answer it in coordinate form, so it's like x, 0 or 0, y. For quadratic function, you can get the axis of symmetry because it is normally U-shaped, whether it's facing up or down. And they have an axis of symmetry in which they mirror the left side to the right side. And the quick way is to use this formula. X equals to minus b over 2a. And again, quadratic function has a vertex, the maximum or minimum coordinate, in which you can get it from x equals minus b over 2a. And then after that, you can find the maximum or minimum values by inputting the x values that you get into the original equation. Okay, going back to what we discussed earlier about one-to-one function in which it has inverse. So function has the inverse when it is one-to-one function. Well, what does that mean? Let's say I have this blue function over here. So when it has an inverse, it means you can mirror that and it will give you another function. So the mirror is the equation y equals to x. So this is the function. Well, the inverse will be mirroring them. So it implies that when function, you go from domain, you get a range. Inverse is reversing them. The range of the original function is the domain of the inverse, and then the domain of the function is the range of the inverse because they are reversing from x to y into y to x. So when you put a on the function and you get b, it means that on the inverse you put b, you will get back to a. We can see how it's done in the practice question over here. So a function is defined by fx equals to the square root of x plus 5, where the domain is larger or equal to minus 5. So now we need to determine the domain and the range of function. Well, the domain is already given, so we can just rewrite that. Domain is x, where x is a real number, and we want that x is larger or equal to negative 5. For the range, you can also check that visually. But always remember that whatever inside the square root will give you positive or neutral values because you cannot square root a negative number. So the value of the output is y, also element of real numbers, and y is larger or equal than 0. If you're not sure about the properties of square root, you can input the function in your GDC and then you visualize and you see the nature that it is always above the x-axis or it is above y equals 0. Now we need to find the inverse of square root of 6. Okay, so we understand that we don't have the inverse function here. So the way we can do is we reverse that. We want to find the function where it is equal to square root of 6. So square root x plus 5 is square root of 6, and now we know that the x is 1. So when we input square root of 6 into the inverse function, we will get that the answer is 1. Moving on to quadratic models, so we know that quadratic models, Well, as the name, quadratic, the power highest degree is 2. And the form is ax squared plus bx plus c, where a is not equal to 0. Because if a is 0, then we are losing this. And it becomes a linear form. And we can switch into writing into the standard form. Well, it is a x minus h squared plus k. And the coordinate h and k over here is the vertex. Recalling back that the axis of symmetry is x equals to minus b over 2a. And this is the x coordinate of the vertex. So we can just substitute this to the original function to get the k. So roots, again, it's the x-intercepts. It happens when y equals to 0, and we need to always answer that in coordinate form. For y-intercept, you reverse it, you substitute x equals to 0 to the function, and you will get an answer. You substitute 0, in which you will get that the y equals to c. And again, write it in coordinate form. Now you can pause and read this question because I'm going to solve it in 3, 2, 1. We write down the height in meters from which the coin was thrown. It means that the x is 0. So the height was at 8 when it is thrown. So height is 8. Now we need to calculate the maximum height reached by the coin. So maximum height is at the principle of axis, right? Maximum height, we get that from the axis of symmetry. We get the x coordinate, we substitute back to the function. So first, we can find the coordinate of the vertex. So x vertex is at minus b over 2a. From the function here, we have that the b is 3 and a is minus 0.5. So it is minus 3 over 2 multiplied by minus 0.5, in which we get that the answer is 3. The height is y, so we substitute this to the original function. The h maximum is 8 plus 3 multiplied by 3 minus 0.5 multiplied by 3 squared. And we get that the height maximum is at 12.5. Find the horizontal distance from the base of the wall to the point in which the coin hits the ground. So the wall is on y-axis and it hits the ground on c, so we want to know the c coordinate, especially the x. As it hits the ground, it equals to 0. We can write the function equals to 0. So now we can solve this using GDC. You can visualize that on your GDC and you get that the root is at x, 8. And x resembles the horizontal distance, so the horizontal distance is 8 from the wall. Well, we don't know whether it's in meters or kilometers. The next part is called direct and inverse variation. Direct and inverse variation, it is on your syllabus with the common standard form ax power n. As x keeps changing and going up, it is multiplied with a. And there is a difference between direct and inverse variation. It depends on your n. So if n is larger than 0, it means you have a direct variation by it's continuously going up. Where it is n smaller than 0, it means we have an inverse variation. As x gets larger, the y gets smaller. The key point here is to understand the proportionality. We call it direct proportional and inverse proportional. Direct proportional, let's say we can say a circle area where a is equals to pi r squared. We know that a is proportional to the square of radius because as the radius gets increased, the area is also increased, but by the square of the radius. K is the multiplier constant here, it's pi. For inverse proportional, it means it's reverse. So as one variable goes up, the other variable goes down. So for example, in Charles' law of gases, in this case, when T2 is increasing, it means the denominator gets larger, right? So the value of V1 becomes decreasing, where we hold that the V2 and T1 as a constant. Let's go to the practice question. The distance traveled of a freely falling object is proportional to the square of the time ball in seconds. So a football dropped from the top of school buildings falls a distance of 19.6 meters in the first 2 seconds. So now we need to show that dt is 4.9 multiplied by t squared. So from the question, we understand that d is directly proportional to the time squared. And here is the exact statement: proportional to the square of the time of the fall. So the equation is d equals to k t squared. Now we got a coordinate over here. When t is 2, the distance is 19.6. So 19.6 equals to k multiplied by 2 being squared. So we get that k is 4.9. So therefore dt is 4.9 multiplied by t squared. Now we need to sketch the curve of d for t larger than 0, clearly showing that the point is 2, 19.6. In this case, I screenshot on what I already see on the GDC, but I need to adjust some things. So first, this is not y, we can say it is d, and the x-axis resembles of t. So when t equals to 2, the y or the distance is 19.6. And the window that I set is x from 0 to 5, and the y is from 0 to 100. You can adjust it into any which you like, as long as it shows that the 2, 19.6 is there. The distance covered by quadcopter drone undertaking vertical landing can be modeled by st equals to 8t, where t is the time in seconds after the landing commences. The football is dropped at the same time as the drone commences landing from the same height of the school building. The football covers more distance than the drone, where t is larger than p. So find the value of p. So we have the distance by football, and we also have distance by drone. This says that there is a time where football will be covering more distance than the drone. So we can visualize that on GDC. So you want to know when dt is larger than st, in which 4.9t squared is larger than 8t. So the quickest way is for you to find the intersection of 4.9t squared and 8t, in which you get that they intersect over here. We know that dt will be larger than st when t is equals to this. So t is larger than 1.63265 ... That means that this is the p. We can round that into 3 seconds. So it is 1.63 seconds. Another function that you're going to be having is exponential. It's about growth and decay. So commonly, it will give in this notation k multiplied by a power x plus c. A is not equals to 1, or else it will just be a constant. And a and k is larger than 0. So you know that it is a growth function where a is larger than 1. And if it's a fraction between 0 and 1, it is a decay function. If the power is negative x, it is the reverse. So a larger 1 becomes decay, and between 0 and 1 becomes growth on power negative. An exponential function has a horizontal asymptote at y equals to c. So you can just write y equals to whatever number in the function. And then the y-intercept happens when x is 0. A power 0 is always 1, so k plus c is indeed the y-intercept on that. There is a connection between compound interest. When it is becoming continuous, it will become an exponential growth function as k multiplied by e power the rate multiplied by x plus c. And for the exam, it is commonly used to model a real-life situation when there is a constant change in the form of percentage. So let's say 5% higher, 3% less. It means that the function is exponential. Here is the exam style question. The amount in milligrams of medical drug in time t hours injected is dt equals to this. Before this injection, the amount of the drug in body is 0. So write down the initial dose of the drug. Well, we know that initial dose of the drug, it means that when it is firstly injected, time equals to 0. So you can just write d0, and then you want to solve that 23 multiplied by 0.85 power 0. This equals to 1, so the initial dose is 23. And the unit of measurement is milligram. Or you can remember that the y-intercept happens when x is 0, right? This is k, a power x plus c equals to 0. When x or t is 0, Well, it's K plus C, in which there is no C, so the answer is 23 directly. The percentage of the drug that leaves the body each hour. This is what you want to know, the percentage that leaves each hour. You know that from this equation, if T improves per hour by 1, so the remaining is 85% of each hour. So if 1, you go up to 2, you multiply it again with 85%. So from the initial, it means that the remaining is 85%. So to get to know how much it leaves, you can subtract with 85%, in which you get 15%. Or if you're confused, as you know D0, you can find D1, in which it is 23 multiplied by 0.85. It is 19.55 milligram. So you want to know the difference of this, it's the leaving, and you divide that with the original at 23. So from 23 to 19.55, we need to subtract them to find how much it leaves. And then we divide them with the original, in which it is 23. We want to find that in percentage, and we will also get that the result is 15% too. Now we need to find the amount of the drug 10 hours after the injection. It means T equals to 10. So we can substitute directly. D10 is 23 multiplied by 0.85 power 10. So it is 4.52811 ... and we can round that into 3 significant figures, in which we will get 4.53 milligram. Going on to the cubic models. So the degree of polynomial is 3, in which we get ax cubed, bx squared, cx plus d. That's the generic form. And there are some properties that you need to know, which is it has definitely one point of inflection. So point of inflection means that the graph changing its shape from smiley to sad or vice versa. So from this graph, you can see it is from sad, it changed into smiley. From sad, at this point, it changed into smiley. From sad, at this point, around that point, it changed into smiley. That point where it changed from sad to smiley or smiley to sad, we call that point of inflection. So how about the roots? The roots can be up to the degree of polynomial. The degree of polynomial is 3, so it can be 1 root, 2 roots, or 3 roots. At this graph, we have 1 root. This graph, we have 3 roots. And at this graph, we have 2 roots. So it can be 1 root, 3 roots, or 2 roots, depending on the model that you have. And it can have one minimum and maximum turning point. In this case, we don't have. In this part, we have local maximum, local minimum, and so that's on this, we have local maximum and local minimum. Well, they might have minimum and maximum turning point, but they will always have point of inflection, and that is what you need to take note for the exam. These are the most common appearance for your exam, but it could also be on another topic in which we'll see the exam question style. You can pause and read this question, as I'm going to discuss them in 3, 2, 1. So now we need to write down one feature that suggests this is a cubic function. To answer this question, we can just write one out of these 3 that especially applies. You know that the graph was from sad into smiley, so you can say that there is a point of inflection. So it has a point of inflection. You can also write it has one local maximum and a local minimum. Or you can also write that it has 3 roots, so it is a cubic model. So now we have the expression in the generic form, and we get some points. So write down the value of d. So every function question that asks for the last variable, it is just a constant. It is usually asking that when t is equals to 0, so you will get the d directly. So the d is -5, in which I can write it over here. So now number 2, we need to write 3 simultaneous questions for A, B, C. As we have 3 other points, we can write 3 simultaneous equations for them. So first is 1a plus 1b plus 1c plus -5 is equals to 3, in which we can rearrange them. We will get an 8, and then we get 8a plus 4b plus 2c plus -5. It will equal to -1. We can arrange them, and we will get 4. And now we have 27a plus 9b plus 3c equals to 0. Now we need to solve them to get the ABC. We can use polynomial simultaneous solver, or we can use matrix. So I'm solving with matrix, and we get that the result is A equals to 2, B equals to minus 12, and C equals to 18. So now we have the full cubic model already with the value of A, B, C, and D. Negative value means that graduate is in debt. So now we need to find the total length of time in years for which graduate is expected to be in debt. So this is in debt, and then not in debt, and then in debt again, and then not in debt. We need to find the time from here to here as 1 is in debt, and also here to here as 1 is in debt. We need to find the duration of that. So here what you need to do is you sketch them, and you find all the roots, and you find the total from here to here and here to here, in which the total time will be, first is 0.358 ... minus 0, and then you add with 3.810 ... minus 1.831 ... So when you round that into 3SF, you'll get the total time in that is 2.34 years. Now we have the last one over here, which is called sinusoidal model. So it's the graph of sine or cos function. And don't worry, both of them has the similar properties. So the amplitude you calculate with this formula. So the y max minus y min, and then divided by 2. For the principle of axis, you change the sign from minus into plus. And that's where you also get the constant d. But the principal axis equation is y equals this value. And from the period, the duration of period is resembled by 360 degrees over the constant b. Or if you don't get any much information, but you can see where is the max and where is minimum, you can subtract them with the bracket absolute value and multiply that with 2. Because one period means it's from maximum to maximum or minimum to other minimum. For your exam, it is important to remember that whatever the value of b, it will make theta, right? So theta, sine theta, has a minimum value of minus 1 and the maximum value of 1. And so does for cosine. The minimum is minus 1 and the maximum is 1. So whenever you got a maximum point coordinate or the minimum, use that first, and you can get the D and the A even though you don't have any information about B yet. Because in the maximum, the cos will be 1, and in minimum, the cos will be minus 1. So does for sine. At the maximum, it's 1. At the minimum, it's minus 1. Commonly, it is out on the paper to exam, in which I will show you down below. You can read this question, and I will solve it in 3, 2, 1. Now I have a 2-point minimum and maximum. And Boris think it might be modeled by quadratic equation. So we need to write one reason why quadratic is not a good model. So we can read again the context of the diagram, why the sinusoidal model would be more proper rather than the quadratic. Well, you can see that the daylight hours is periodic, right? It is repeating every day. So we can write that it is not a good model to be quadratic because number of the hours of daylight per day is repeating across a number of years. Now, Paula thinks that there is a better model, which is using cosine for specific values of A, B, and D. And now we need to find the amplitude. Okay, so for B1, we know that the amplitude is y max, which is 16, subtracted by y minimum, which is 8, over 2, and we get that the amplitude is 4. Now we need to find the period. So for the period, we can go back to the graph, and it happens from minimum to minimum, in which it is 12 months. Again, this question is asking period, not the B value. So we can say that the period is 12. Or the other formula that I told you. So we have x max and x minimum. We subtract them, which is 6, and then we multiply with 2, and we get 12. Another part is we need to find the equation of principle of axis. So equation is y equals the y max, which is 16, so 16, plus the minimum, which is 8, over 2. So the equation is y equals to 12. This means that the d value is also 12. Remember that principal axis in the form of equation, so you need to always write down the y equals. So now we need to find the equation of this form. we got the A value and we got the D from the principle of axis. So now we need to find the B. So we know that one period in which it is 12 is equals to 360 degree over B. So we know that B is 30 degree. So the final equation is amplitude multiplied by cos inside 30 degrees multiplied by T plus D, which is it is 12. And that is the final equation of the model. For the first use of the model, find the length of time when there are more 10 hours and 30 minutes of daylight per day. Visually, you might want to draw a horizontal line at 10.5 and find the intersections so you know when it has more 10.5 hours of daylight per day. So for D, you can equate first that the 4 cos 30 degree multiplied by time plus 12, will equal to 0.5. So solving with GDC, you try to guess the value nearby 3. You'll get that the T1 is 2.26585 ... And if you second guess that with the value nearby 9, you can get that the T2 is at 9.73414 ... Because you want to find the duration here, you can subtract T2 with T1. So the length of the time is 9.73414 ... subtracted by 2.26585 ... And final answer, rounding that to 3SF, is 7.47 months. So again, because it is the length of time and we calculate everything in months, we can just keep them in months unless they ask to switch that into 7 months and certain days. If they need to, you can multiply 0.47. 1 month is 30 days, so 0.47 multiplied by 30 days and write that down as number of days. So now we have the true maximum number of daylight is 16 hours and 14 minutes. So we need to calculate the percentage of error in the maximum number that Boris recorded in the diagram. So for E, so we know that the value of approximation was 16, right? And now we get that the information of exact value at 16 hours 14 minutes. We need to convert that into hours first. And using GDC, convert that to decimal, it's 0.2333 repeating. So we have the percentage error formula in the formula book, in which it is the value of approximated subtracted by the value of exact. We divide that with the exact value, and then we multiply it with 100%, in which we will get the percentage of error is 1.44%. If you have more mathematics questions or you need tutoring supports, click link on the description below and subscribe to this channel.